Good afternoon, dear members, friends from the industry, our esteemed speakers, Mr. Rajesh Nath, Managing Director of VDMA and our co-moderator. A hearty welcome to all of you in today's interactive web seminar on improving productivity and profitability, the role of value engineering in waste elimination, organized by VDMA India. Friends, we all hope you and your families and employees are all safe and sound during the well. Myself, Sandeep Roy, based out of the Calcutta office of VDMA, and will be taking you through the initial part of the today's webinar. Friends, as per Ayurveda and the Indian philosophy, we have 5 basic elements in nature which are associated with the health of human beings, namely Prithvi, earth, Jal, water, Vayu, air, Agni, fire, and Akash, ether. Any disorder in the human body indicates imbalance of one or more of these elements. Similarly, a manufacturing plant has 5 basic elements which govern its performance. These elements are assets, processes, place, utilities, and people. A comprehensive manufacturing excellence program has to ensure that performance of all these 5 elements is improved to deliver a right quality product at least conversion cost with highest productivity and safety with optimum inventory at right time. Further, a process becomes valuable when it has less non-value adding activities and meets customer expectation in terms of time and quality. Manufacturing processes often have a lot of waste which increase the lead time. Use of lean tools like VSM and 7 Waste are very effective in identifying waste and designing new processes. Producing more and better with less is increasingly gaining momentum because of the scarce resources of materials coupled with the present pandemic. Friends, COVID-19 has made us think of new ways of running businesses. It is also an opportunity for all the businesses to revisit their strategies and make improvement in productivity and remain sustainable. Against this backdrop, and taking forward our initiative of the last web seminar on frugal engineering and to reinforce the ideas of managing cost and wastes in this crisis period, I would like to introduce and welcome a very illustrious experts joining us from diverse field of manufacturing in today's web seminar. Mr. T.R. Parasuraman, President and Whole-Time Director and Board of Member Toyota Industries Engine Private Limited. Mr. A.N. Chandramouli, Board Member Starag India Private Limited. Mr. Frank Eward, Executive Vice President and Global Head E-R&D Tata Technologies Limited. Friends, moving forward, a very brief intro on the VDMA. VDMA is the largest industrial association of Europe. It started its journey 127 years before. It has around 3,300 members presently. The total members will have of employment of around 1.03 million employees. The total companies produces are hoping 232 billion worth of productions, out of which 78% are exported worldwide. For ease of operation, VDMA is divided into 38 engineering verticals. Friends, understanding the potential of the BRICS nations in 90s, VDMA started with this operation from India and followed by later on expanded to China, Brazil and Russia. Apart from that, VDMA has also European offices in Belgium and also have a small offices in Japan. Friends, before we move on, we would like to remind all of you that you can post all your questions during the webinar under the question and answer section, which would be answered during the Q&A session. Now I would like to briefly introduce all 3 of our speakers, starting with Mr. Parasuram. Mr. Parasuram is the graduate in mechanical engineering from Madras University, MS in technology operations from B.S. Pilani Management training from IIM Bangalore with more than 33 years of total experience including manufacturing, production engineering, HR, and administration, and Toyota way of management. He worked for TVS Brakes India for about 13 years and in Toyota Motor Corporation Japan from between 1999 to 2000 before moving to his current assignments. In addition, he closely interacts with the government bodies of local and national level and trade bodies such as IMTMA, BCIC, ACMA, CII, QCFI. Mr. Parasudaman is presently the president of the Bangalore Chamber of Commerce. A hearty welcome to Mr. Parasudaman. Over to Mr. Chandramouli. Mr. Chandramouli is a graduate in mechanical engineering from NIT Trichy and a postgraduate in management from IIM Calcutta. In his 4 decades of industrial career, Mr. Chandramouli has held many leadership positions in diverse industries such as machine tools, Starrag and Makino, electrical industry Lab, Cooper, consumer products, Unilever, Bronze division, and truck division of Tata Motors, to name a few. Mr. Chandramouli superannuated as the Managing Director of the Starrag India and is now the board member since June 2017. Prior to Starrag, he was holding the position as CEO of Makino India, a Japanese MNC in machine tools. Thank you very much, Mr. Chandramouli. Regarding Mr. Frank Ivier serves as the Executive Vice President and the Global Head E&R&D Tata Technologies. Frank is a multicultural, business-oriented senior executive with over 25 years of leadership experience in working for engineering service provider, leading automotive OEM and suppliers, along with other manufacturing companies across APAC and Europe. His work spans drivers across such as system integration, automotive interiors, lean manufacturing, multi-site plant and production efficiency, among others. Frank excels at combining skill from different functional areas such as engineering, manufacturing, and program management to provide growth and strategic direction to the global companies. Very hearty welcome to you, Frank. So before I invite our first speaker, friends, we would like to take a first poll questions. May I request my colleague Manohar to share the first question on the first poll? Yes. So what below is not included in the concept of value engineering applicable to automobile engineering? So there are 4 options are given: reducing cost of product without reducing value, improving value to customers regardless of cost, improving value with same cost as before, improving value coupled with reduced cost. May I request our audience to kindly participate in the poll and give your valuable inputs. Let's wait for the time being. Can I have the results now, Manoj? So friends, the results is 26% is reducing cost of product without reducing the value. But the over 44% said improving value to customers regardless of cost. So that's the value over the cost. So thank you very much, audience. Now I would like to invite our first speaker who talk on Muda in manufacturing for your address. Over to you, Mr. Parashuram. Can you unmute Mr. Parashuram, please?
You're able to hear me?
Yes, please.
Yeah, very good evening, Mr. Rajesh Nath, Mr. Sandeep Roy, Mr. Frank, Mr. Chandramouli, and dear participants. First of all, it gives me a great pleasure and privilege to talk on a very important subject, waste in manufacturing, which is very dear to my heart. So today, this topic is all the more relevant in the current situation, given the kind of COVID pandemic. All the organizations are looking at how to eliminate waste, how to reduce at every opportunity by involving all the employees across levels, across functions, and collaborating with organizations. So in my speech, I thought I will divide this into 5 sections. I would call it as 5 P's. First is the product, then the process, then the plant, then the people, then the performance. So starting with the product, so everything starts from, you know, the product. Fitness for use. What kind of value the product is able to add to the customer. And once we have a right product, then I think we have a very, very strong foundation. And improving that product continuously, I think that is the value add to the customer. In fact, I always talk of the example of iPad. When iPad was launched, you know, many people asked Steve Jobs, how did you launch this wonderful product? In fact, we hardly see you talking to the customer, but how did you launch this wonderful product? In fact, how we are able to get the perception of the customer to be in so wonderful way. So I think what I was told, when iPad was launched, we had palm tops, desktops, laptops. But what Apple did, they went to a level, it is beyond customer excellence, customer delight. They went to a level where even a customer cannot think of that product. Even a customer cannot imagine that product. That's the kind of value add. And I think very beautifully he describes Steve Jobs. He calls Epiphany, which is a level where there is a cloud busting of ideas and where you have reached a very, very high level of excellence. Even a customer cannot imagine that kind of a level. I think that is the kind of value creation. And once iPad was launched, I think it goes without saying there is no substitute for this product. Unbelievable product. And again, it is going through several Kaizens, you know, with every launch. And we can see the huge difference between the first iPad and the current generation in terms of light, in terms of compactness, in terms of precision, in terms of the extensive applications, in terms of memory. Today, we have iPads available for 1 terabyte. So I think that's the kind of a power. So the product is a fundamental thing. So again, in product, when we make the drawing, I think it's very, very important. The feedback from manufacturing, I think we rotate this PTCA. So whenever the product is launched, you know, several months, several years before we start the design review, and all the feedback from the end user, the manufacturing people, customer, they're all taken and fed back to the product design. So how do we simplify the material, make it more competent, more cheaper? How do we change the specification so that the price becomes much cheaper? How do we achieve the net shaping? As I said, fitness for use. So what is not adding value to the customer is a waste. In fact, how do we change the process? For example, from a normal turning operation to a cold forming, where you don't have to completely machine. You can use it in as-is condition. For example, like caliper pistons or cold form. And today, cold forming has innumerable applications. And even in terms of checking, whether we can design in such a way that this can go through a non-destructive checking. Today, eddy current checker is a very common thing. See, when we do the induction hardening, normally we have a cut check of those components, be it a crankshaft or a connecting, whatever typical component. But today we have eddy current tester where we can do a non-destructive testing, and this can be a dynamic across on the line. And the signal is, the feedback is passed back to the process, and the process is continuously improved. Therefore, I think this product design is very important in terms of the kind of precision, right precision with right size and right specification. And it should not add too much of value. It should add the right value. Therefore, it starts always at the product level. And that is why the value engineering, VAVE activity is very important. Even after the launch, I think VAVE we can save millions of dollars. Every stage we should identify, benchmark with a similar products on the market, then understand the difference between this function and the other function, then whether we can improve the value continuously. I think this is the first P. Then the second P is a process. Process again is starting from manufacturing. How do we design the process? Then how do you ensure that the process is very much controlled? Rejections are controlled, and we are able to achieve the quality assurance at source. We call it as jikote konketsu in Japanese, or even jizoka. Jizoka is a powerful Japanese word. It's a Toyota word, I would say. The ability of a process to stop in case it detects an abnormality. Whatever be the thing, the first part is produced as NG, then the line should automatically stop. It need not be automatic. It can be a simple poke-yoke where the rejection doesn't go to the next process. I think this is the height of quality assurance, which means there is no continual flow of defective to the next process. I think if you're able to achieve the quality at source, we call it the maker quality, which means rejection is a major source of manufacturing defect. And rejections are not controlled, then it becomes a chronic problem. Then it affects the overall effectiveness of the equipment, and which in turn will impact the overall plant efficiency and lead to huge costs. So when you look at plant process, there are many kinds of losses happening. For example, when you see a typical plant, machine breakdowns, breakdown losses, setup losses, minor stoppages, speed losses. When I say speed losses, both the machine's speed losses and the human speed losses. For example, the machine is set to a normal speed. Let us say it's a CNC machining center or a turning center. You have the rapid traverse rates, X, Y, Z, and the fourth axis, let us say the B axis. Let us say the rapid traverse rates are coming down over a period of time. That's a speed loss. Whereas the operators are not able to perform the standardized work in the standardized pace, that is called the speed loss. So machine speed loss is also very important. Human speed loss is also very important. Then we have the yield losses. Sometimes the processes don't start in the beginning. They need some warming up. Honing machine is a typical warming up cycle where the machine doesn't start. So you have to 15 minutes, you have to give some jogging cycle so that the system gets heated up and there's a balance. Similarly, sometimes the broaching machine. So therefore, these are all called the yield losses. Then the management losses. For example, absenteeism is a management loss. For example, there is a huge absenteeism on a particular day. Definitely, it is an attributable management loss. And again, how do you manage the absenteeism? For example, you plan a huge absenteeism cover of 15% because of challenging situation. Let us say in India, typically we have many festivals like Deepavali, Magara Shankaranti or Dashara. So immediately after the festival, there is a huge rise of absenteeism. Some organizations plan 15% or 10%. Then again, what happens during a normal day? Those 15% of the people or 10% of the people are idle. Therefore, this muda is how do we eliminate the fluctuation? I think this is a very powerful word, please note. Elimination of fluctuation is the biggest management theory to control muda. Anything that fluctuates is a huge muda. Absenteeism is fluctuating, it's a muda. Process is fluctuating, it is a muda. Defectives are fluctuating, it is a muda. Cycle times are fluctuating, it is a muda. Breakdowns are fluctuating, it is a muda. Therefore, anything that fluctuates is what we call the unevenness or the mura in Japanese. So we say three things: muri, mura, and muda. Muri is impossible to do. When I say impossible to do, difficult to do. For example, I find an operator struggling to load and unload a job. That is called as muri. Muri sagyo, we say in Japanese. Very difficult to do a job. So what happens is once a person performs a difficult to do job, he will not be able to achieve a consistency in the process. Sometimes he'll be able to achieve the time, sometimes it will go up, sometimes it will come down. Therefore, there is no stability in the process. Once stability is lost, the process capability is lost. Therefore, Muri is very important. So whenever some difficulty to do a job, immediately that should be simplified. This is the first step we should do. Then Mura. Mura is unevenness. Anything that fluctuates is a big Muda. And that will lead to a huge loss of efficiency. I talked about absenteeism. I talked about rejections. I talked about mission breakdowns. I talked about minor stoppages. We call it as chocote, which means a minor stop is not a major breakdown, but it's an irritation. For example, coolant leakage is a minor stoppage. Then some kind of mission door not closing. You go and tap, then it will start working. This is an irritation. So manufacturing can rectify it, but it is a great irritation. This is what we call the chronic issue. Then third thing I talk about, the third M, is Muda. Muda is anything that doesn't add value to a process, to the customer or to a product. So you can see millions of Mudas. In fact, if you look at a manufacturing operation, if from a turned, from a bar, you make a final product to a precise shape, that is a piston. So whatever we turn it out and throw it is a Muda. Chip is not adding any value to the process. So the final product, which really performs, that only adds value to the product. So I would say 99% of our processes in manufacturing doesn't add value. What adds value is that 1%. I think that is a juice. Therefore, how do we eliminate that kind of a 99%? I think that is a challenge all the manufacturing people have. So please remember these three words. Muri, once again I'm telling you, it's impossibility. Mura, which is a fluctuation, and Muda is waste. Again, Muda, you can call umpteen number of waste. Muda of walking, Muda of loading and unloading, Muda of conveyance, Muda of inventory, Muda of management losses, Muda of line balancing, Muda of waiting. So you can call anything in the shop floor. That's why this losses, when I talk about losses, when I walk through the shop floor, you see many losses. Machine breakdown, setup loss, minor stoppages, speed loss, management losses, power losses, line balancing losses, logistics losses. Processes are not balanced. One cycle time in the cellular manufacturing, one machine is running at 10 minutes, other machine is running at 8 minutes. That's a big Muda. So how do I run all the machines at the same cycle time? That is called the line balancing. Even if all the machines run at the same cycle time, still there is a Muda of people, which means a person should not wait in front of a machine. We call it as temachi. Temachi in Japanese is waiting. Therefore, the machine cycle time and the man cycle time should be synchronized. It is like a car driver and the car. The racing car driver and the car should be perfectly synchronized. Then you can win the race. So these are all the Mudas that we talk about in processes. Then correction is a Muda. Again, loss due to correction. Every time you set up a process, it is not stable. Therefore, you keep on correcting the process. That is a big Muda. So it's very important how to achieve the process capability. So process capability and mission capability are a must if you have to achieve a very stable process. Then I talk about the standardized work, which is the DNA of Toyota production system. So how do we perform every operation in a standardized way? A standard is prescribed and people have to operate as per the standard. This is what we call the abnormality management. I think it's a very big subject. I can talk for 2-3 hours, even one day. So please remember this point. When you walk through the shop floor, please ask 3 questions. Is it normal or abnormal? First question. Second question, if it is abnormal, there are 3 reasons it is abnormal. First reason is there is no rule or a standard. Do we have a standard? First question. Second question, standard is there, still why it is abnormal? Is the standard easy to follow? Please ask this question. If I'm not able to follow the standard, I cannot ask my subordinate to execute that. Therefore, how do we simplify the rule? Third is, rule is available, rule is easy to follow, still people don't follow the standard. Then what is the next? Is it been trained or educated? So, ladies and gentlemen, please take these 3 points. Be it a shop floor or institution or any place of work. The reasons for abnormality are only 3. Please ask these questions. First question, do we have a rule? Second question, is the rule easy to follow? Third thing, is the rule educated to people? So once you answer this question, naturally you get the solution. I will tell you a simple example. This is a page of pen. I keep the pen on my pocket, right? I ask the audience, is it normal or abnormal? I keep the pen on this iPad. I ask the question, is it normal or abnormal? Any answer? Supposing I designate a place, let us say, I say that this is a rule. I put the pen in my left pocket, blazer placket. This is my standard. Then I put it in that place, it is normal. If I remove it from that place, it is abnormal. Then why, if it is abnormal, then please ask this question, why it is abnormal? Then first question, as I said, there is a standard, is it there? Second, standard is there, still people don't follow. Then standard, is it easy to follow? Please ask this question. Then please simplify the standard so that everyone can follow. Third is, standard is there, standard is easy to follow, still people don't follow means people are not educated or trained. People are not understood. So once you keep asking these 3 questions, any problem in the shop floor you can solve. And the second most important thing is abnormality management through Genji Genbutsu. Genji Genbutsu is a very, very powerful term in Japanese. Using all our 5 senses and the 6th sense, please go to the point of action and understand what the problem is. Once you do that, once you understand the problem, 99% of the problem is solved. Many times we don't understand the problem and we try to give solution. I think the most important thing I define this is something like 5 blind men talking about a black elephant in a dark night, which is not there. So we tend to imagine ourselves. So once you go to the point of action by yourself using all the 5 senses, for example, not seeing, but observing. There's a big difference between seeing and observing. Where your mind and heart or both are there, that is observation. Observation, you can achieve many, many breakthroughs. Otherwise, it is just physically present, mentally absent. So here, seeing, not seeing, observing. Something is wrong today in the shop floor when you walk through the shop floor. Then hearing. Oh, today something is abnormal. I am hearing some sound, some rattling sound. The bearing is rubbing. So using the ear. Then touching. Oh, when I take the tool or a product, oh, some chattering mark is coming. The tool is not reground, right? Then, smelling. Typically on a Monday morning sickness smell, we say the bacterial contamination, the coolant is not changed. You get a typical smell, so you can change the coolant. Finally, tasting. We use it in the food industry. We use it in our canteen before it is served to our employees. So, using all the 5 senses, and of course the 6th sense, the common sense, mostly uncommon. Using all the senses, going to the point of action where the problem is happening and understanding for yourself is Genji Genbutsu. Once you understand the problem, 99% of the problem is solved. Many times we tend to solve a problem without understanding the problem. The other day I was asking my daughter, what is the problem? She said, you. I didn't understand. So this is very, very important. So powerful concept called Genji Genbutsu. Then we have to prepare a problem solving tool. What we call is as a A3 paper, where we define the problem, understand the current situation, then the background of the problem, then set the ideal condition, current condition, the difference is the gap, then go to the root cause of the problem and through Genji Genbutsu, then make occurrence countermeasure. Please understand, many times when problem happens in shop floor, we tend to solve the problem. I think the problem comes back again, which means it is chronic. We are not understanding the root of the problem. So all the time, until you go to the root of the problem without a bias, try to understand all the reasons, then try to take occurrence countermeasure for each of the reasons without a bias, then we can achieve solution to the problem. Many times the problems come in combination. Problems don't come singly. So 2 or 3 factors in combination, unless we address all the factors, go to the root cause of the problem, take occurrence countermeasure. Occurrence countermeasure means once you take that countermeasure, it will never repeat. For example, I'll tell you a simple example. Let us say a bearing is making a noise. Then I change the bearing. Is it an occurrence countermeasure? Definitely no. Because I don't know why the bearing was rattling. So I need to go to the point of action through Genji Genbutsu, understand the mechanism, physical mechanism analysis. Why that bearing is rattling? Something is touching, something is rubbing. So that physical mechanism we need to understand, then eliminate that cause. Then that is countermeasure. That is occurrence countermeasure. Many times we take countermeasure which are temporary in nature. Therefore, permanent occurrence countermeasure is very, very important. So once we do that, then we make the schedule, then action plan, then follow, then continuously improve, then rotate PDCA. Many times the jovially say PDCA means please do not change anything. PDCA is we need to rotate the PDCA, go to the source, again improve the standard, go to the next level. So why do we need standard to improve manufacturing processes? Because standard is required to understand the difference between normal and abnormal. Once you understand the difference between normal and abnormal, then you can call that as a gap. Then the gap you can solve through Genji Genbutsu. Without a standard, you cannot improve the process. So all the time, please set the target standard, then understand the gap from the current situation, then go to the Genji Genbutsu and solve this problem. So jovially I used to say, somebody asked in India, many trains are running late. Why do you need a railway timetable? So to know that trains are running late, you need a timetable. That is the starting point. Once you know that, then you go to the next process. Then how do we achieve this kind of a waste in Gemba? We have several ways. We have to involve members, quality circles, Gemba Kaizens, cross-functional teams, and we also call it as Ichibyo Kaizen. Ichibyo Kaizen, 1 second Kaizen, which means members can give suggestions to reduce 1 second in the Gemba. I think small drops of water make a mighty ocean. Therefore, involving them.
Sorry, you have 1 minute more to complete, Mr. Professor.
Thank you very much. Yes. So using all these processes, we have to understand, then eliminate the waste continuously. Then the third P is a plant P. Plant is logistics losses due to mission layout, walking time is more. Then there is crisscrossing of parts and material. So material and information flow should be synchronized. This is the plant efficiency so that the stock is minimal, flow is optimal. So plant is very, very important. Then the people, I think, how do we develop the quality of people? Then the quality of thinking mind. Therefore, how do we develop leaders so that the waste is minimized, so that people are able to give that focus on prioritized issues? And finally, performance, plant performance. How do I reduce the energy losses? How do I reduce the loss of coolant? How do I reduce the loss of my consumables? Therefore, all the 5 P's should be synchronized through eliminate waste. So today I didn't want to talk about general waste. I thought I will touch upon some of the principles that we follow so that it will be of some value add to you. Thank you very much for your patient hearing. Thank you. God bless.
Thank you. Thank you, Mr. Parashuran, for a very insightful presentation address, combining the 5 pillars as process, plant, people, performance, and product. Thank you very much. And friends, now before we invite our next speakers, we would like to go for the second poll questions. Can I have the second poll, please? Yeah. So this question is related to the machine tool industry. Machine tool design using value engineering concept means we should not focus on design with very best features and stringent specification, design based on customer expectation with optimum specification, understanding the customer application and design the machine, and eliminate unwanted features which add no value to customers. I request our participants kindly to participate like last time and give you a valuable inputs. wait for a few seconds and then we close the poll. Yeah. Can I have the results, please? Yeah. See, 38% people are saying that design with very best features and stringent specification, very close connected with the 36% which say eliminate unwanted features which add no value to customers. I think these are the two major traits which is comparing to one each other. And I would request Mr. Chandramouli also into that way to cover it in your presentation. So over to you, Mr. Chandramouli, for your presentation on value engineering in machine tool industry.
Thank you, Sandeep. Really, thank you so much for the quiz also. Interesting to see the answers, and if you can give me the authority to open my PowerPoint, you can manage the time carefully. But if I exceed, please do give me a shout on.
Yeah, thank you. Yeah, please.
So, are you able to see my screen?
Yes, please carry on. In a full screen.
Are you able to see my screen now?
Yes, please.
Okay. Thank you so much to VDMA, Mr. Rajesh Nath, and Sandeep, Mr. Manohar, and our colleagues, Mr. Parashuraman, Mr. Frank, and all the participants who are listening to us. It's a great pleasure to talk in the middle of this corona crisis, the concept of value engineering and elimination of waste. And elimination of waste, ladies and gentlemen, is to start at the product stage, as Mr. Parashuraman said, the 5 P's. The first P being the product, the second being the process, and the product and process are quite interrelated, along with the plant, the people, and the performance. So fortunately, he has set the road for me, and Starog has got a slogan called engineering precisely what you value. I'm very happy to know that even in our slogan, the word value is coming. The word engineering is also coming. Engineering precisely, so that means quality is alluded there. And what you value, the word you here, I believe all of you will understand, refers to the customer. Therefore, when you did the quiz, you understood many of the points are related to the customer. And the customer is not only the king, but is the only purpose for which we all exist. On that note, I would like to move on and tell you in what way the customer measures the value when it comes to the machine tool. Engineering precisely what you value, I said. So there are many aspects of value. I don't want to go into the detail, but safety, quality, efficiency, reliability, flexibility, and in the recent past, after the Industry 4.0, we also get additional value benefits for the customer, namely visibility, traceability, and predictability. The Industry 4.0 addresses visibility, traceability, and predictability, whereas our conventional manufacturing logic was always considering safety, quality, efficiency, reliability, and flexibility. Flexibility is very important when it comes to the variety management and customized production. Mini mass production, mini, M-I-N-I, mini mass production. He is talking about customized production where variety is to be handled with velocity and volume. So flexibility becomes extremely important. And if those are the values of the customer, I would like to consider a machine tool design and the process of using the machine. Consider and a package of 3-in-1 package. I call it the overall equipment effectiveness or the 3-in-1 package. Why do you call it 3-in-1 package? Because the 3 are interrelated to each other. Many times we talk about productivity, quality, and availability, namely the uptime of the machine, as 3 independent parameters. Unfortunately or fortunately, it is not so. They are 3 interrelated parameters. I'm sorry, there is some typing mistake there. Machine availability stands for downtime measurement, reliability of the machine tool, and service response. Even if it's some reliability issue, how quickly we can fix the problem. That will improve the availability. Machine productivity depends on cycle time, performance, which means productivity, and performance also means including quality. But this is affected by parameters like torque, power, etc. Machine quality depends on accuracy, consistency, repeatability, process capability, and so on and so forth. But when this overall equipment effectiveness is leading to reliability, accuracy, and long-term precision, etc., you will see if all of them are 90%, the product gives you only 73%. If all of them are 97%, the product gives you 91%. So our aim in manufacturing, design, and value engineering is to maximize the OEE. That's what I want to summarize our entire discussion is woven around not just features, not just some fashionable parameters, but overall equipment effectiveness. I move on a little faster now because of the time constraint given by VDMA. We have to move fast. The same thing I could do for 2 hours. Now, high productivity and cycle time reduction. Whereas the Japanese were focusing on high-speed machining centers because they're primarily, most of the components in Japanese automobile industry are made of non-ferrous like aluminum materials. Whereas in the German concept, from 1960s onwards, they were looking at the high-performance machining centers. Whereas in Germany, they were looking at materials, cast iron, steel, and then tougher material like super alloys, etc. So that's a history of machine tool design, and we have to look at cutting time reduction, non-cutting time reduction, pallet change time reduction, and so on and so forth. So when you talk about the value engineering, the design concept has to take the optimum between high-speed machining centers and high-performance machining centers. Now moving on, we all must be wondering what is value engineering definition. I think by now all of you are familiar that we have to look at value not with standalone, but along with cost. Some of the questions in the quiz were alluding to the ratio between value and cost. For a small incremental extra cost, if you are able to get a very large increase in value of the product, namely the machine tool in this case, then that is a very good achievement of value engineering. Conversely, at the same cost, if I can increase the value, or I do it at the lower cost, but give you the defined benefits to the customer. Another way of looking is the optimization or trade-off between cost and function. Functionality is related to quality, or related to productivity, or related to the downtime of the machine, as we already talked about. And above all, frugal innovation. Mr. Parasuram talked about that iPad concept. It is a lower cost compared to a laptop, but it has got more benefits to the customer. We can carry it wherever we want. And last but not the least is a modular value addition. Value engineering and value addition are two sides of the same coin. I will explain this in my examples. I will also talk about cost per part machine and total life cost concept and total system concept. So there are three things, namely cost per part, total life cost, and system cost. Let us talk some examples here so we can understand it better. We will come to another very, very important point, value chain. When we talk about a value chain, the final customer may be a tractor manufacturer, but he is manufacturing a gearbox. A gearbox is going into the tractor. But to manufacture the gearbox, you have a machining center. But inside the machining center, there is a rotary table. So there is a subsystem called rotary table, which is part of a machining center, leading to the machining of gearbox with the help of fixtures and tools, and finally leading to the assembly of a tractor. And in this value chain, what is very, very important is at every stage, are we increasing the value at the same cost or marginally incremental cost, the value to the customer is increasing. Now, one example we did with a very nice customer in Chennai with a very small compact machine. They were delighted because the same process competition was giving 2 machines. Even though the capacity was requiring 1.6 machines, you cannot supply 1.6 machines. So all my competitors were offering 2 machines. And our people were so ingenious in the fixture design that all the setup changes can be managed with 1 machine. You can see the fixture concept there very quickly, and you can see the fixtures are placed on both sides of the fixture. The hydraulics are so well designed, and therefore the productivity and the capacity could be achieved just giving 1 machine. We call it the tooled up solution, which most of you in the audience are very familiar with. The reason I'm giving this example, ladies and gentlemen, is a value is not just the machine tool, but together with clamping fixtures, together with cutting tools, and sometimes flexible automation, and sometimes robotic automation, we try to satisfy the customer and delight the customer. So there is a value enhancement through a turnkey tooled up solution. Now, there is a real life case study I did in Chandigarh when I was in Starog as a managing director, now continue to be on the board membership. All competitors were giving 8 machines for the same capacity, and we achieved the same thing with 7 machines, proven with turnkey tooled up, and that gives a very low cost per part. The unit cost of per machine may be high, but the cost per part, which is calculated as running cost divided by output per hour, and the running cost in this case is a summation of tool cost, fixture cost, consumable cost, maintenance cost, energy cost, downtime cost, so on and so forth. All this cost totaled up divided by output per hour makes it cost per part. Ladies and gentlemen, not only the total number of machines came down, but the cost per part was the lowest in the industry, and there was, without any discussion, the order was obtained and proven in practice over 3 to 5 years, still going on very strong. Now, another example is the total life cost. Earlier we talked about total cost per part. Now, when you talk about investment, many people look at the value of the machine is very high to invest in the beginning. Even MSMEs say it's not affordable. Here is an example where a machine tool industry purchased my machines, and because we could give a proof and also proven in actual practice with references and actual case studies thereafter, that the total life cost over a period of 10 years, not the initial 1 year or 2 years, over a period of 10 years, including machine investment cost, turnkey cost, running cost, maintenance cost, underline very important, maintenance cost, annual depreciation cost, when all these are added up and taken care in the form of volume and variety, customized production, the total life cost was the lowest in this case. So, gentlemen and ladies, every benefit can be measured in terms of cost. So, value and cost are the two sides of the balancing equation. Now, let me move on to quickly some examples of the unit machine design. So far, whatever you saw was about how to give a tooled up solution. You know, customer is never looking for a machine or a product. The customer is always looking for a solution, because he is in the business of manufacturing, let's say, a cylinder block or a cylinder head or a gearbox or whatever. It could be a valve industry, it could be aircraft parts, any part. But he is looking for a solution to do with his component with faster, better, and cheaper, with the best quality, delivery, and cost, and with the flexible production with multiple variety of parts. So he is not interested in the basic machine. He is looking at the solution. However, I would like to now take you through, even in the basic machine, the way we can do value engineering and value addition. Now, when we do that, always start with the customer. My advice to all my friends here is, instead of looking at the product or the machine or the technology, even Industry 4.0, you should ignore it and look at, is it useful for the customer? Here is an example of small ferrous and non-ferrous parts of passenger car, light commercial vehicle, tractors, trucks, and so on and so forth. Multiple shapes and sizes. Metallurgy could be non-ferrous to ferrous, sometimes super alloys. Accuracy levels could be anywhere from 1 micron to 7 micron positioning accuracies, and geometric accuracies again varying widely. Then volumes could be anywhere from 10,000 per annum to 1 million per annum. Variety of parts again could be just couple of types or as many as 150 types. There was an example of slack adjusting mechanism. Over here I'm showing the arrow. Yeah, there are 144 types, and how the company managed to do it. So in my career, I found that unless and until you start with the customer, there is no way you can do a value engineering exercise. Now moving on to examples, what I'm talking. When we design the machine at the starting stage, we have to do an external benchmarking, and also we have to do an internal benchmarking. Now, what is external benchmarking? Benchmarking, when we are designing a machine, we are looking at the best in the world of maybe Japanese and German and Korean and other manufacturers, and look at what are the best things they are doing in their own way, and what are the things that we can learn in terms of.
Yeah. Just to cut short, Mr. Chandramouli, you have another 3 minutes to go, please.
I'm coming very fast. Don't
Yeah.
worry. And basically emulating the good ideas from anywhere in the world is very, very important without diluting the brand image. And we come to the benchmarking. Our own product, we took the 30-year-old design product, there is a 20-year-old design product, there is a 10-year-old design product, and we came with a design which is a composite value engineered product. And what are the things we did? One example is the conveyor evacuation system. The original designs had a very expensive central truck conveyor, Then we came to a dual screw conveyor, which is cheaper than this. And then we came to only bed flush for chip evacuation. In this case, not only the cost is reduced, but the value is improved through reliability, because reliability is depending on the number of moving parts. And as you could see, the number of moving parts comes down as we move from one design to another. I don't want to take many examples. This is an example of a polymer granite bed where rigidity, accuracy, and surface finish, all of them are improved at the same time at a lower cost compared to a typical cast iron bed. Another example is a multi-purpose power pack for hydraulics and another composite system for lubrication. In this case, the total system cost is very, very important, and a hermetically sealed hydraulic power pack, of course, is more expensive than other simple power packs, but the total footprint of the machine became so compact that the overall cost of the equipment became much less than the competitor's machine. And likewise, innovative design on NC rotary table was achieved through a modular approach. It is not offered in the standard machine, but we keep adding such options to make the machine more and more valuable to the customer. And another such example is even what an accuracy can be achieved through a small Kaizen or an innovation using a central bore and an orientation bore. Any number of times you take out the fixture and put it back, the repeatability is achieved. Another example of cylindrical roller ball bearings on the linear guide, improving the durability and accuracy. And yet another example of using a magnetic scale, inductomagnetic scale, to eliminate positioning errors. And it's a direct measurement technology to improve the positioning accuracy of the machine. The precision was improved at a lower cost. And extremely important example is when the tool pots are made optimum, finally we can make the entire tool design at a system cost reduced drastically. Another example, the chain magazine is not flexible, whereas we went to a tower magazine. As the customer's volume and variety increased, that we can keep on adding more and more towers to take care of the cutting tools which are loaded onto this magazine, scalable with business growth in volume and variety. I am forced to go faster, but we are almost there. I think we may not have time for the video, but suffice to say, the value engineered products assume a lot of significance due to increasing customer demands during this corona period, continuing input material cost, increase in the face of product price competitiveness, Muda elimination, of course, and COVID era has really opened the eyes, and the competitive world makes it demands from faster, better, and cheaper to survive and grow as an organization. In order to facilitate the achievement of the required quality and cost objectives for the manufacture of a product design solution, it is extremely important to value engineering at the earliest possible stage of design. Failure to get this right in the beginning often results in late engineering changes with their associated problems of high cost and lead time reduction, and having to live with components that are of poor quality or expensive to make at a later stage. Hence, value engineering, ladies and gentlemen, is an exercise to balance cost on the one hand to the value the customer derives out of the product. The customer is a focus in doing value engineering and not just the cost. And value analysis and value engineering are therefore the foundation of success. And I wish all of you the very best. We may not have time for the 2.5 minute video, but if Mr. Rajesh Nath would like to see the video for the audience, he can play the video and I'll give a small commentary on the video. Thank you, sir. Thank you so much.
Thank you, Mr. Chandramouli, for very enriching presentations with lots of practical examples. Thank you very much. Now, quickly move on to we invite our last poll. May I request my colleague to post the last poll of our poll question, please? Last poll, Manohar, please. Yeah. Why is COVID pandemic driving the need of the value engineering in industry? 4 reasons are given there. It's a golden opportunity to eliminate waste in industry. Customer cannot pay normal price for his survival. We have to cut losses due to lower business volume revenue, and innovation is not affordable at this crisis juncture. Like last 2 times, I will request our audience also to kindly participate this time also and give you a valuable input. We wait for some time and then we take the results, please. Can I have the results, please? Yeah. It's a golden opportunity. 49% said to eliminate waste in the industry. There's a close competitors. 38% say we have to cut losses due to lower business revenue. So with that, I would like to invite our last speaker, Frank Ewert, for his presentation on reimagining post-pandemic business with value engineering and manufacturing efficiency. May I also request Frank also to touch upon this results of the survey of the question as also in your presentation, Frank. Over to you, Frank.
Okay, thank you very much, Sandeep. Maybe you can move to the
Yes.
presentation now, please.
Yes.
So,
Yes.
thank you, Mr. Rajesh Nath, for the organization of that seminar and for giving me the opportunity to present here our view on reimagining the post-pandemic business with value engineering and manufacturing efficiency. Thank you, Mr. Parasun Ranma and Mr. Chandramouli, for your very interesting presentation before to me, and I will try to complement it with some of our elements. And thank you to all participants for your time and attention to the presentation. So the presentation is very dense. There is a lot of information. I will not be able to go through everything due to time limitation, but you will have access to the presentation after the seminar, and we would be more than happy to go in more details if there are any points that you would like to deep dive with us. Okay, next slide, please. Can you move to next slide, please?
Next slide, I think. Yeah.
Okay, so if we okay, so yeah, what we will go through first of all is about what we can see from the news, and that's one point which is important. There are a lot of communication which have been around in the internet and in the press about what could be the world after the post-COVID crisis, and what is a new normal, which is after the crisis, what is living with the crisis. So there are a few points which are coming out of it. Is there is a need of low-cost product. There is a need also for cash conservation, whether it is for the industries, and as well for the consumers. There is a need of flexible manufacturing, and there are some, if we take about the automotive part, some changes in the car habits. Next slide, please. If we look at a very high level, what are the new normal and what will we bring to the market, is there are two main considerations. One is on the OEM side, where there is a clear move that we can see from fresh investment into new vehicles to a renewed focus, which is mainly on existing platform. And this is part of what I mentioned before of the need of cash preservation and the need of reuse and not reinventing and not spending a lot of the resources for that. So that's one part which is coming on the OEM. On the consumer side, what we see is that there is a clear shift, which is from the share mobility, where there was a tendency of increasing of share mobilities, which has slowed down due to the crisis in most of the countries, and there is a move to an ownership of vehicles, and with a move which is important with smaller cars. So if we look at this, and in a summary, we can say that all stakeholders, what is expected is to have better product and more features at low cost, more features because some features are coming linked to the pandemic situation. We can see already some filters which are already proposed, even in retrofit, to be able to be protected against some viruses. There are also some features which are already developed. Some of them are very, I would say, handmade ones, but some of them start to be very elaborative about creating some separated space in the car. There are some solutions about cleaning the surface and so on. So all of that brings a need of more features. However, at the same time, there is a demand of low cost and cash preservation. So that's a very strong trend that we can see in the market today. Next slide, please. So when we look at now the value chain, how the value chain has been impacted by the new normal, it has been impacted in many areas. And if we can summarize, one is about the supply chain continuity. When the crisis arrived, when all the different transportation stopped, when people couldn't move, there was some issues and some big challenges about logistics. And so there is a real question about what should be the real logistic and how should be the network of suppliers and customers in the new normal. That could be with a more regional supply chain. It could be also with a combination of low cost areas for suppliers and some close suppliers to limit the risk. There is also a procurement challenge to be addressed, because like in any crisis, there will be unfortunately, some company which will not survive from that crisis, and there is a need of looking at what is the robustness of suppliers, how they are able to evaluate very quickly to the new normal, and being able to continue to supply parts. There will be a need of recalibrating engineering. So there is an extensive reverse engineering, which has been started, and this is linked to what I mentioned before, is how to do more, better for low cost, and that will require some very quick engineering activities. And there is also a need of optimization of production with more flexibility, with also reorganizing of the plant, and mainly by the need of social distanciation, which is required now to prevent people against the COVID-19. Next slide, please. So we have now a small movie which explains you what we have doing with regard to tear down and benchmarking and VAV. You can launch the video, please.
Yeah, we will run the video separately, actually. Frank.
Yes, please.
Yeah.
I think the video has stopped now.
Just a moment. Video is now coming up, I think. It's trying.
Okay, thank you.
Yeah, please continue.
Yeah, if you can come back to the presentation.
Yes, we'll just.
Please. Yeah. Okay, so now we will go in more detail. Thank you very much for sharing the movie and about the organization, what we're doing for value engineering and manufacturing efficiency. Okay, next slide, please. So on the value engineering, and there is a real link, and that's the way we have built up our approach, which is when we do our value engineering, which is going through the focus on cost reduction, the retrofit on existing platforms, the new features, the new variant strategies, increase and the increase of automation. All of that we're doing with a real link and analysis, which is done on product and process at the same time. And we believe that it's important because the real savings and the real improvements that we will do are coming from both the value, the engineering and the manufacturing side. So we have built up an approach which takes care of both of them, and that taking care also of the new requirement from the customer, the sourcing models that I mentioned previously about the China, continue to have sourcing from India, Asia, and China, but also from other countries, to have some business model disruption, so completely rethinking about how we can do the manufacturing, but also the engineering of parts, and the optimization of the workflow and the production schedule. So all of that is done through the analysis that we are doing with those two approaches on engineering and manufacturing. Next slide, please. So when we define the product strategy, and that's part of the challenge, the product strategy, we are considering with our customers the manufacturing strategy, the make or buy strategy, which is important, the servicing strategy, also the platform, what is common, what is unique in any vehicles, what are the vehicle specification on each vehicle, but also linked to the platform strategy, what are the cost targets, what are the objectives and the competition. What are the feature and variant strategy? What could be the supply chain? How to optimize the supply chain? And what is the PAL strategy with regard to the vehicle which is defined? That's what is the base of understanding the product strategy. Then to align the value of the product developed and the manufacturing associated to the most optimum way. Okay. Next slide, please. What we're doing, and that was already well mentioned, is we're focusing really on the waste that we have in manufacturing efficiency to try to delay them and to remove them. So we are using the approach of the identification and the tracking of the 8 major wastes, which are coming from inventory, management, transportation, motion, non-utilized talents, waiting, overproduction, excess processes and defects. And all the time we are comparing that to what is in place, what could be the improvement, and create that continuous improvement work, which is to try to reduce and to eliminate waste. And there are always possibilities to do it. Next slide, please. Next, please. On the value engineering, now what we're really doing, and the value engineering is not one-time process, is really should be seen as a continuous improvement. And as we can always improve on the manufacturing side with the waste reduction, on the value engineering there are always possibilities to improve. So it's going through some purely value engineering activities, through engineering design optimization, product weight and cost optimization. Then there is an activity of tear down and benchmarking to understand what is the best in the class solutions which are available on the market, what the competition is doing. Then we have a cost engineering activity, which is after the tear down and benchmarking, evaluating of what is the cost of the product, cost which will include the product cost and also some estimation of manufacturing cost. Then some studies about sourcing, what is the best way of sourcing those parts, with regard to local sourcing or regional sourcing or global sourcing. And then there are also some activities of reverse engineering, so to rebuild from the part which are already existing, and then redesign those parts to be able to recreate them. And this is a continuous process that we can do it again and again, as the improvement is never stop, and there are always ways of doing better. Okay, next slide, please. And what we are doing for the waste elimination is, and that's very important during that pandemic way, and we have developed what we call the digital twin, which is to create a digital model, 100% copy of what is a physical plant, And what is very important when we have that is to be able to work on from the digital work to simulate all the, first to identify all the different wasted, so to make some specific analysis on this, and then to start to make some modification on the digital plan to try the changes to see if we're not creating, for example, some bottlenecks in some areas which would create some other waste, trying to eliminate one waste and create some more waste somewhere else. So we have those models which are running and which we are doing with our customers, and that will give us a possibility to really simulate and anticipate all the improvement we can do, and after implement them in the physical one. And that was very important during the pandemic, because at a point of time, and mainly in India, there was some real limitation about the possibility for people to move from one area to another. There was also some constraints with some curfew in some areas. So with the customer who had those digital plans, we were able to really anticipate what would be the new normal, how we could reorganize the line, for example, to put more automation, to avoid people to be close together, so to respect some social distance in a plan, which is one of the constraints which has come from the COVID-19, how to create more flexibility with the demand, which will fluctuate differently with a drop of production. So we have been able, while everybody was working from home, to really anticipate what should be done without getting physical access to the plan. And that's really something which is highly valuable for a company to be able to make all that digital work before the implementation. And then when the implementation comes, it's also coming with much less disruption in the physical production. Next slide, please. What is important is, because it's a process, it could apply to any industry. So we have experience in automotive and industrial heavy machinery, but when we look at the process and how to do it, it could be applied to any type of industry, whether it is with the value engineering activities, with benchmarking, costing, and so on, and also with a digital plan and with the activity of the improvement of the manufacturing side and reduction of waste. Next slide, please. So a few case study. I will be very, very quick on that to keep some time for the questions. So we have here studies that we have done for leading European OEMs who wanted to enter the Indian market. So we made a deep dive analysis of some competitor vehicles. We proposed through a cross-functional team some different studies, and we proposed to them some possibilities of the vehicles, of what would fit for the best on the Indian market, and what could be the best solutions that could be competitive on what we analyze, but also on what we understand from the market. And the result is that we could, through that study, be able to propose 5% of waste saving and 6% of cost saving compared to the understanding that they had before coming to this study of the Indian market. So we help them to improve the entry to the market. Okay, we go to the next one. Another example that we had, which is now was a different one. It was a startup automotive company in the Asian region, in a country where there was very limited production in automotive production. So we helped them to analyze again the products that they could do, analyze the possibility to localize some components, or to use some suppliers on the region. So by doing all those studies with them, those analyses and some proposal of where to put the value for the car, understanding the vehicles they wanted to put on the vehicle, we were able to propose them some solutions with the potential of cost savings from 7 to 9% on sedan and SUV.
Yeah, Frank, we have one more minute. Yeah.
Good. I just have 2 slides, so it will be done in 1 minute. Okay. Yeah. This one was for an IHM customer that we have worked for an excavator, where we have helped them to identify and to work with some suppliers locally. And that globally, that bring to them as a supplier was in USA, with the work that we have done up to 23% of cost saving on the product. Okay, next slide. Yeah. Okay, and then this one was about the digital twin and virtual commissioning that we have done, and predictive maintenance is what we have done with a steel producer one of the largest world steel producer. And on this one, we have done exactly what I explained you about the digital twin, the analysis from that digital twin, and finding some possibilities of making significant cost saving up to 30% for the commissioning of the activities. And there are also continuously some activity with them to find even some more savings that we can get from that approach of digital twin parts to optimize from the digital side and then apply on the physical plant. Next slide, please. So as a summary, so the COVID-19 has a huge impact to the entire manufacturing value chain. The company needs to respond fast and navigate through the new normal, which is unknown by everybody. A successful organization in the future will be those that offer high value at low cost. So there is really that pressure. Value engineering and manufacturing efficiency will be a key imperative for companies to future-proof their business. Cost drivers should be integrated early into the product design. And finally, cost optimization, increased flexibility, and waste elimination will help companies to emerge stronger out of the crisis. Thank you very much for your attention.
Thank you, Frank. Such an interesting presentation. Friends, we have three interesting address and presentation combining. Now we'll move to the question and answer session. I invite Mr. Nath to take on the proceedings. Mr. Nath is the face of the VDMA since last 2 decades. He is accorded with the Cross of Order of the Merit, the highest civilian award from the German president for promoting Indo-German trade. He has a degree in Bachelor of Engineering in Mechanical with distinction. He has also had a business management degree from Indian Institute of Management, Joka 2004. Over to you, Mr. Nath.
Yeah, thank you, Sandeep. I think a hearty thanks to all our three speakers. We had excellent presentations. So I would like to thank our esteemed speakers, Mr. T.R. Parsuraman, President and whole-time Director and Board Member, Toyota Industries Engine Private Limited, Mr. Chandramouli, Board Member, Starag India, and Mr. Frank Everard, Executive Vice President and Global Head, ER&D, Tata Technologies Limited. So thank you very much. I think really good, insightful, engaging presentations. And we have a lot of questions that have also come in. Mr. Parsuraman, maybe I will, since you mentioned you have to leave, so I will just address the first question to you quickly so that you could answer the question before you depart. Mr. Parsuraman, you mentioned about Mura, that is elimination of fluctuation. So when the load factor and demand in times like COVID is fluctuating, how can this effectively be managed considering manpower, raw material, the supply chain, Mr. Parsuraman? Mr. Parsuraman, I think you're muted. If you could just unmute yourself. Yes.
Okay. Yeah. Thanks a lot. See, the most important thing is the tag time. See, how do we manage the tag time in operations? Like, for example, the volume is too high, then we reduce the takt. Let us say, then the volume is low, we increase the takt. So by changing the takt, we are able to adjust the manpower. So changing the takt also is not an easy thing, which means the entire process, assembly, machining, and all the related process or logistics flow, all the supplier flow, all these things should be adjusted. Therefore, the ability to change the takt depending on the customer demand, this is the heart of the whole thing. So once the takt is adjusted or increased, definitely we can alter the manpower and also the supply chain. See, definitely supply chain in India is definitely a very, very big challenge. So there is no, assurance to get a steady flow from the suppliers these times. Therefore, an optimal inventory we plan and a risk management. So wherever there is a challenge, that buffer is very important actually. However, the tag time management is very, very important and basics. Therefore, once you're able to change the tag, the number of people will get adjusted and the entire system is planned to pull at that rate. So this requires a lot of fine tuning and learning process. Of course, if you ask me, are you achieving perfect levels? Definitely the answer is no. But there is always a trend towards perfection. I think that's all I can say.
Right. The second question also I will quickly put to you, Mr. Parsuraman, is would efficient design play a major role in reducing machining. What are your views on this, Mr. President?
See, this is very, very super important, I would say. See, when you are making the layout, I think the most important thing is how slim the layout is, which means space is the biggest value. See, 1 square meter or 1 cubic meter is gold actually in operations, which means why space is important. Closer the machines you put, the logistics distance becomes very small. Then space gets optimized. Conveyance becomes more easier. Then the workflow becomes more smoother. At the same time, you should also have provision to have a proper maintenance. Maintenance people should be able to enter. The machine should be very well maintained. There should be approach to the important points of the machine for lubrication, oiling, and cleaning. Therefore, space efficiency is one of the very, very key benchmarkings I always say. Whenever I look at a new factory, I always look at the space utilization. So the space utilization is a very important KPI. And secondly, I talked about little bit about M&I. M&I is machine, man and information flow, which means material and information flow. M&I is material, how the materials flow and how the information flow. Normally the materials and information, they flow in the opposite direction. So we always prepare a M&I diagram where the entire layout is mapped and what path the material is flowing, what path the information is flowing, and at every point what is the optimal inventory. So once I look at the M&I diagram, I can talk about how efficient the plant is. So wherever there is a kind of inventory storage, that is a muda. Therefore, the whole process is how to optimize and remove that inventory. So this whole process is eliminating waste in the form of reduction of inventory, reduction of space, ultimately reduction of people, and ultimately this is a continuous chain. Therefore, I think the key to this is the sharp eye for observation. That is why I talked about Gemba. See, Gemba is definitely not seeing. I think definitely 5 minutes of watching the standardized work in a particular process, it needs a lot of skill. You can see millions of things like waiting time, the flow of the process, what kind of abnormalities are happening, what kind of minor stoppages are happening in the process, whether the process is rhythmic, whether the smooth flow is happening, materials are getting fed properly. Any muda, you can always find out. That is why these experts, when they come from Toyota or any parts of the world, they're all literal veterans actually, like a master chef. They observe the Gemba for 5 minutes or 10 minutes or 15 minutes, 1 hour. I think it is a gold, I would say, because each piece of advice, I think it can be a mountain of activities to follow like a pyramid top. Therefore, I think layout is a very, very important. I remember for my earlier layout of the engine plant, we had close to 40-50 revisions actually. And nearly 70-80 experts have gone through that. Because once you commit that layout, then the whole plant is fixed, which means it is a cost competitiveness. So I think more slimmer the layout and no chutes is the best way. Chutes are a storage point for inventory. So if you're able to have, that's why we talk about Hyzens. Hyzen is along the material flow, along the assembly flow. Parts required for that assembly is fed along the process, which means what is required for one particular assembly, it is fed across. Because if you have long chutes, then it is a big, huge inventory, huge material flow, maintaining that first in, first out. It's a complicated problem. I think it's a very super important. Layout is the base of everything.
Thank you. Thank you, Mr. Vatsuraman, for these, I think, very valuable tips what you have given to the viewers also. Now, let me move on to Mr. Chandramouli. Yeah, thank you, Mr. Vatsuraman. Mr. Chandramouli, you had mentioned, given this example of cost per part. Now, cost per part would have relevance only for high output from the machine. How can it be used as an argument for high quality precision part, but which has limited number? So would this argumentation still hold good, Mr. Chandramouli?
Yes, it all the more holds good. And then we have to bring in what is called the flexible manufacturing systems. I have given 3 flexible manufacturing systems in this country, where the combination of volume and variety, and the third V is the velocity. Now, this is an example of a valve industry in oil and gas production. Another example is the machine tool industry with multiple types of machines. And a third example is the defense industry to make 45 different engines for our defense production. I have to be a little careful on that description of the third one. Now, in these three flexible manufacturing system, the cost per part is still very important, Mr. Rajesh Nath, and the question is very, very important. It is nothing to do with mass production. There is a misunderstanding that, as Parasuram was mentioning, when he said takt time has to modify, that means as the volumes are changing, he didn't have time to elaborate. But the main point is, unless and until you have a flexible concept where volume is still taken care, but the setup changes for each variety of part are simplified and minimized. The time to set up change is minimized through very ingenious automation systems. The days have gone when single minute exchange of die and single minute exchange of fixture, they're all old concepts. Now it is automation brought in. Automation has not displaced people. I would like to add that in another forum, but Mr. Frank is also will confirm that he comes from the European automated world. But having worked in Pune, he will still confirm there is no displacement of people. The volume increases. At the same time, he showed the number of passenger cars, trucks and tractors and commercial vehicles variety is also increasing. The combination is still achievable. Cost per part in a flexible manufacturing system. The example I showed you is a turning center manufacturer in Bangalore with the FMS system.
Right. Thank you, Mr. Chandramouli. Now let me come to Frank. Frank, how effective would artificial intelligence be in eliminating waste and increase the value in engineering?
Well, that's very important question, and that's true. That's using artificial intelligence, I would say, is the next step of the journey that I presented, and that's today part of the analysis that we are doing. We are also working on solutions on artificial intelligence, which is able to manage a level of data which is much higher than any engineer can do. So that's typically that's through a journey that we are exploring, that we have already developed. And when we think about the complete digital plant, and some of the plants are very, very complex, when we work on finding the good balance of the waste elimination, it's important that sometimes a computer could be smarter than an engineer to find the right balance, because as I explained, most of the time when we try to gain on one side, for example, on the stock level, then we may lose on some other areas. So it's always a question of balance, and finding the best equation and the best solution could be helped a lot by artificial intelligence. And then step by step, instead of just doing the analysis, the system will come to and bring solutions.
Thank you, Frank. Now, Mr. Chandramouli, there's a question again for you. Sometimes customer requirement cannot be assessed completely, leading to a complex situation. What are your views here, Mr. Chandramouli?
There is a very important thing which is called the open-ended questions. Unless and until we go into the hearts and minds of the customer by asking the 5W and 1H. What is the volume of the customer? What is the part he wants to manufacture? What is the business he is in? Several what's. Then the why. Why does he want to add one more machine? Or he wants to add one more line? There's several wheres and whens. When does he want to install this capacity? And by who is affected by it? And by whom? And we always look into the question that is he going to place an order on a machine or not? Unfortunately, our sales engineers have been tuned to go and focus on getting an order. But train them to ask the right question of the 5W and 1H, we call the open-ended question, because in these 6 questions, customer can never say yes or no. In a closed question, will you give me order? Yes. Will you not give me order? No. That is the last question. Probably you will get at the end of the negotiation or discussion process. So, unless and until it is incorrect to say that we will not be able to understand the customer's requirement. So, the question itself, what is asked by the respected audience, has got a little bit of anomaly in it. Whether it is a standard machine, whether it is a customized machine called special purpose machines, whether it is a tooled up machine called the turnkey solution. In every case, we must understand the customer's requirement. The gentleman who was asking the question, I am ready to part with my phone number and a mail ID to him, and I will give him a free advice on any example that he has got where he can design or supply a product or an equipment or a solution without understanding the customer's requirement. Impossible.
Right. Thank you, Mr. Chandramouli. Frank, coming as a further question to your statements earlier, now this is a little tough one. Is there an index for an optimal level of automation based on type and size of the manufacturing enterprise?
No, there is no real index that we can do, and it's really a case by case studies that should be done, and I would say it's so specific. We can compare automation on the same industry. I would say compare one supplier to another. That's possible, but there is no index that says that a certain percentage is optimum. And also things are moving because, again, making the link to that COVID situation, the level of automation may increase in a plant, not for economical reason, which was before the main reason why automation came, but more for the difficulties that were first about social distanciation, which is needed in the plant, and also by the fact that because of the lockdown situations that we may face, a plant with automation may be able to still run, or to run with less people, so with more flexibility. So I would say this is also changing with time. So unfortunately, there is no index where we can measure, but more, I would say, bringing some expertise to advise and bring solutions to see what could be the right level of automation for a given industry.
Thank you. Mr. Chandramouli, would you like to add something to that?
That it has always been a debate whether automation is displacing people or it is augmenting the people's effort. The debate has ended now with COVID. Even when people are missing, such as a migrant labor, the companies like Toyota producing 70% capacity, as Parasuraman mentioned, or for that matter Tata, is now possible without any exception by what is called partial automation. It is not the complete automation we are talking about. In fact, alluding to the previous question, I just want to go back to the previous question you asked to me. What I want to link the question asked to Frank and my previous question. If you cannot understand the customer's requirement in the beginning, it does not matter. If you could understand 50% of his requirement, you offer him a general purpose machine, GPM as we call it. Not a special purpose machine, not a rigid structures with fixtures, etc., but a flexible concept of a general purpose machine. And if there are more than one machine, do not go for a gantry kind of a layout. Go for a FMS system where you can change the parts at any time. And there's a scalability with a modular approach. I forgot to mention this point in the previous question. The scalability with modular approach. That means I can go on adding machines or fixtures or tools, etc., as the business of the customer grows. Now in the COVID era, many people, I know my good friend in TVS Motor, that handlebar line was modified to make ventilators. Look at the ventilator, it looks similar to the handlebar of a scooter. So flexibility is a key, and there are many case studies of Siemens and others, I'm sure Tata Technology will have, where existing lines are being modified with partial automation for altogether new products. People who are in FMCG industry are moving to food and beverage industry, and conversely. People who have been doing automobiles and in two-wheelers and three-wheelers, they are adapting to healthcare products. So there is no escape from, there is no limit to flexibility. Of course, flexibility comes with additional cost, which is have to be taken into account. But instead of doing nothing during COVID, at least we are able to do at 70% volume. Thank you.
Thank you. The last question for today, Frank, I'll put to you is that now due to the pandemic, the supply chain disruptions we have seen. So to mitigate risk in the future, is Tata also planning to reduce the imports and look to develop more local suppliers or vendors, Frank?
There are some trends about that to have more local suppliers. Okay, so there are some trends, and again, it will be a case by case. And the trends that could also that we can see, and specifically in the automotive, when we have global programs, is to have at least two base of suppliers. I would say to limit the risk, but it's not that simple, because now that with most of the global OEMs, they are producing the same car in several countries. You know, it's not possible, it's not viable on an investment point of view to have suppliers on each country. So it's again, it's a specific study which are done with also some limitation of risk, as it was mentioned about the stock management. So how maybe to have more stock in some areas to be able to manage disruption of the supply chain. But that requires some real studies and thinking differently, that everything could stop in a couple of days or weeks, that it happened when the pandemic happened. It's what it was. So, but again, all of that is balanced by the need of cost reduction, of cash management, because developing a new supplier in a country requires quite a lot of investment. So I would say all of that is a question of risk management and finding solution about the best balance and the best way of continuously production. Yeah?
Right. I think it's a sensitive balance. One would have to find the right balance then.
Yeah, absolutely.
Thank you.
Just wanted to add value to Frank's inputs, excellent input by Frank. I came to know that now there is an acceleration of the blockchain concept. The reason being, instead of a linear OEM tier 1, tier 2, tier 3 job shop, which is very in automobile industry or aerospace industry, etc. Now, because of the great invisible entity called supplier, and the invisible entity called customer, and the invisible entity called worker, operator. So all the three resources, namely demand side, supply side, and resource side, are severely affected. So in the blockchain concept, the networking of suppliers, rather than a linear chain, the networking of suppliers with the data of the supplier into each block. I attended some webinars. That's where I understood. I don't have a personal experience of blockchain, where people are now looking at it in an accelerated manner, how to use blockchains to overcome this supply chain problem. Because instead of going to the tier 1 and tier 2, the OEM can straight away now talk to the tier 3 or the job shop. He is not undermining the commercial process between the tier 1 and tier 2, but at least he will come to know whether the quantity is available with the quality at the right timing. It has nothing to do with the commercial process of price and cost. And this is one input I understood. The second one I would like to add, maybe for the benefit of the audience, several experiments and actuals have gone across the world, especially in England, of using additive manufacturing at the decentralized approach by changing the supply chain. If I am unable to get that part, okay, that vendor is closed, is not having enough workers, I will quickly install additive manufacturing and get those parts. At least momentarily, I can continue my manufacturing of certain items, especially in the aerospace industry with turbine blades and small blisks and impellers. It is already happening. It is also happening in some of the other automobile parts as well. It is not easy because certain surface finish requirements are difficult to achieve with additive manufacturing. But the speed to market has been now accelerated by the COVID. And now people are realizing that additive manufacturing is no more a fashionable seminar terminology, but it is going to help in overcoming the corona. Thank you, sir.
Right. Thank you. Thank you for these valuable inputs, Mr. Chandramouli and Frank. Thank you so much. So I would like to conclude now. The value engineering is a value enhancing technique, a proven method for improving product and process performance by changing materials, designs, and systems, and aims to maximize function while minimizing the cost. I would like to sum it up. Value engineering is not a concept. It's a method, a definable, repeatable method. So friends, on behalf of the German Engineering Federation, VDMA, we would like to thank all our speakers, Frank, Mr. Chandramouli, and also Mr. Pasuraman. And we would like to thank the audience also. We had some very senior people joining the discussion today or taking part in the audience. So thank you very much for joining us in such large numbers. And thank you, Sandeep, for for the smooth conduct of this webinar. So friends, stay safe, stay well, and stay optimistic, and all the best, and have a nice weekend, and maybe a webinar-free weekend. Thank you. Right.
Okay.
Bye.
Thank you very much.
Right.
Thank you.
Thank you.
Thank you.
Bye.
Thank you so much.
Thank you.
Thank you so much.
Thank you.
Thank you.
Thank you, Mr. Frank. Nice meeting you, Mr. Nath,
Nice.
Sandeep,
Thank you.
and Mr.